Hi, today I'm going to talk about the 5 types of reactions and how to predict products for those reactions. The first reaction we're going to talk about is synthesis. In a synthesis reaction, you have only one product on the right side, and you have simpler reactants on the left side. So when you're doing the predicting products, there's different types of synthesis reactions. So group 1 metals and group 2 metals will react with oxygen to form metal oxides. So an example would be lithium metal, so it's going to be a solid, reacts with oxygen, and remember that oxygen is diatomic. And then it's going to produce the metal oxide. So when I write the formula for this, I do need to balance charge. I need to remember, so this is just my thinking, that lithium is +1, oxygen is -2. And we can also balance this. So we have 2 lithiums here, so we would want to put a 2 in front. And then you can see that we have 2 oxygens, so we would need to put a 2 here. That changes my lithium to 4. So then I would just erase this 2 and make it into a 4. Another type of synthesis reaction would be a group 2 metal, like calcium. And calcium metal will react again with diatomic oxygen to form, and again, my thinking, I have to balance charge. Calcium is +2, oxygen's -2, so the formula is going to be CaO. Balancing this one, you can see that we have 2 oxygens on the reactant side, so I would have to put a 2 over here. Now I have 2 calcium, so I would put a 2 in front of the calcium. Another type of synthesis reaction is a nonmetal reacting with oxygen to form a nonmetal oxide. So, for example, hydrogen is a nonmetal, and it's diatomic, so it's going to be H2 plus oxygen will form dihydrogen monoxide, which is water. Balancing, you can see that we have 2 oxygens, so we would need 2, so I would put a 2 in front. Now I have 4 hydrogens, so I would put a 2 here. Metals can also undergo synthesis reactions with the halogens. If you remember, halogens are group 17. Example, sodium can react with chlorine gas, and chlorine is another one of the diatomics. And then they're going to form just one compound because it's a synthesis reaction, and that would be sodium chloride. My bubble, my thinking is sodium is plus, chloride's minus, so that's how I know the formula. Balancing, I have 2 chlorines, so I would need to put a 2. Now I have 2 sodiums, so I would need to put a 2. Oxides can also react with water and produce metal hydroxides. So calcium oxide, a metal oxide, can react with water, and then we get a metal hydroxide. So the metal is calcium, and it's going to be with hydroxide. So my thinking is calcium is +2, hydroxide's minus. So the formula is going to be CaOH, and then don't forget the parentheses. You need to have 2 of the O and 2 of the H, or 2 of that polyatomic ion. This is one where because you have a hydroxide, when you balance, it's helpful to write water as HOH. And then, let me show you. When I think of it this way, I can see that I have, well, either way, I guess I think I was balanced. Sorry, I didn't need to. I have H2O. Let's just leave it at that. I'm sorry. Anyways, we'll just keep going. So in this case, I have already been balanced. I have 2 oxygens right here and on the reactant side, and then I have 2 hydrogens, and I have 2 hydrogens right there. There's more synthesis reactions. You can also have a non-metal oxide react with water to produce an oxyacid. So in this case, sulfur dioxide is our non-metal oxide. Non-metal oxide will react with water to form an oxyacid. And this oxyacid would be H2SO3, which is sulfurous acid. You can also have a non-metal oxide like sulfur dioxide. Here's our non-metal, and it's an oxide because of this oxygen. Reacts with another metal oxide, metal, and then you form a salt. And the salt here would be calcium sulfite. So you end up with calcium and the polyatomic ion sulfite. And balancing charge has already been done because calcium is +2, sulfite is -2. The next type of reaction that we're going to talk about is decomposition. Decomposition is the opposite of synthesis. You will have just one thing, one reactant breaking up into simpler elements or elements and compounds, but something smaller. So sometimes decomposition reactions happen because of electrolysis. So for example, water can decompose. So sometimes we'll write above the arrow electricity, and it will break into or decompose into its elements. And realizing those are both diatomic molecules, balancing this reaction, you can see that we would need 2 oxygens, so we would put a 2 over here. Now we have 4 hydrogens, so we would need a 2 here. There is also many more types of decomposition reactions. One of them that we saw in the lab that we did is a metal carbonate will decompose into a metal oxide and carbon dioxide. Remember, we tested that by taking a wood splint, and the wood splint went out because it was in the presence of carbon dioxide. So an example, lithium carbonate will decompose. We'll put a little triangle here because you have to use heat for this to happen. Then we're going to get a metal oxide. So the metal is lithium with oxygen. Just my thinking is lithium is plus, oxygen's -2, so that's how I know the chemical formula. And carbon dioxide. And that one is balanced. Another decomposition reaction can happen with a metal hydroxide. For example, aluminum hydroxide will decompose into a metal oxide, which would be aluminum oxide and water. So this is another example of a decomposition reaction. We should balance this. So balancing it, we can see that we have 2 aluminum, so we would need a 2. And then we have 6 oxygen and 6 hydrogen. So we could put a 3 here. Now we have 6 hydrogen. We have 3 oxygen here plus these 3, which also gives us 6. Another decomposition reaction is when we take a metal chlorate, and we can also heat the metal chlorate. So potassium chlorate, we can heat that and it will decompose into the metal chloride. The metal is potassium with chloride. Potassium's plus, chloride's minus, so that's why the chemical formula is KCl, plus oxygen gas. So if we were to do this one in the lab when we did a wood split test, the wood split would have actually lit itself on fire even more, so it would be oxygen. In this problem, you can see that we have 2 oxygens and 3, so we would want to have 6. I would put a 3 and a 2, and now I have 2 potassiums and 2 chlorines, so I would want to put a 2 here. Some more decomposition reactions. Acids will decompose into nonmetal oxides and water. So carbonic acid, it came from carbonate. So the formula would be H2CO3 because carbonate is -2. Decomposes into a nonmetal oxide and water. So water. And then the nonmetal oxide would be carbon dioxide. Another one, sulfurous acid. This came from ite. So sulfite is SO3, it's -2. We would get water. And in this case, we would get sulfur dioxide. We also have single replacement reactions. These are where you have one single element and you have a compound. That single element, if it's a metal, it will replace the metal. And you will end up with a new compound and a new metal that's by itself. It's also possible that A could be a nonmetal, and then that nonmetal would replace the nonmetal. So we would end up with BA plus C. When we do these reactions, we want to use the activity series. In the activity series, the metal or the nonmetal that's doing the replacing needs to be higher, which means it's more reactive, so the reaction can happen. So, for example, lithium metal plus magnesium chloride. So, metal, metal. And what I want to do is I want to find them. Here's lithium, here's magnesium. So because lithium is higher, it's more reactive. So this can happen. The lithium will go in, the magnesium will come out. So magnesium will now be alone, and the lithium will be with the chloride. The formula is based on charges and balancing those charges. To balance this equation, we would want to put a 2 to balance the chlorides, and then a 2 to balance the lithium. Another example, copper plus sodium chloride. And again, it would be the metal replacing the metal. So what I want to do is come over to my activity series, and I find copper and I find sodium,